In this lab, we will compute for each band the hash value for each document based on the R integers in the band. We will retain this in this lab. It retains a list of maps where each map has the hash value, has the key, and a list of doc IDs with the corresponding hash value. Assign 25 to B. B equal 25. So 25 is the optimal number of bands that we found before. For band number in range B, that is from 0 to 24, hash value to document list equal empty curly braces. When we print that, that will print 25 empty list. For band number in range B, hash function equal get universal hash function for integer list of number of docs in R. R is equal to 4. We found the number of rows for each band, that is the optimal value, and that was 4. When we print that, it will print the 25 universal hash function. And the get universal hash function for integer list has this function. Now we already have signature matrix and it is given like this. The length of the transpose of signature matrix, that will be the number of columns index 3430. For band number in range B, let band data equal signature matrix of rows band number times R to band number plus 1 times R. And this will give 4 rows of data. So for example, if the band number is 4, then the signature matrix will be read from rows 4 times, and the R is the optimal number of rows for each band, that is 4. So 16, row number 16 to 20. For band number in range B, hash function equal get universal hash functions for integer list. So it will get 25 universal hash function. Then let band data equals signature matrix from rows band number times R to band number plus 1 times R in all the columns. Let hash values equal np dot apply along axis hash function 0 band data, and it gives this. Now the length of hash values, which are these hash values here, np dot apply along x-axis, the hash values are these, and the length of the hash value is 3430. So there are 3430 values in the hash value array for each universal function. So hash value to document list mapping per band is this one. So for each band, let's compute the hash value for each document. So we have already done that. Yeah. So let's run this again, and let's run this again. Let's have a look. So let a get hash value to document list mapping band pair band equal get hash value to document list mapping pair band of signature matrix, comma B, comma R, and comma number of dogs. B and R are the optimal values. Signature matrix. So if I insert a new column, so we have signature matrix like this. Let's print the number of documents. Index 3430 documents. So get hash value to document list mapping per band of signature matrix and the optimal values of B and R and the number of documents. And when we print that get hash value to document list mapping, so it calls this function get hash value to document list mapping per band, and which is this one. Let's run this again and then run this, and so we get this. So for get hash value to, so that for the hash value 23,393, the document ID is 0. For the hash value 19,920, the document IDs are 212, 34, 68, and so on. Let's show working here. Hash value to document list mapping per band equal get hash value to document list mapping of signature matrix B R number of docs. For hash value to document list in hash value to document list mapping per band, print hash value to document list, and it gives this. Let's run this function again. And let's run this function. So hash value to document list. So it prints all the hash values. Yeah. So all the mapping of it. So for the hash value 16,067, document ID is 0. For the hash value 2,761, the document IDs are 2, 12, 34, 68, 79, and so on. Now show working. So let hash value to document list mapping per band equal get hash value to document list mapping per band of signature matrix B, R, and number of docs. For hash value to document list in hash value to document list mapping per band, for hash value in hash value to document list, print hash value. So the hash values are this. Let's run it again. Yeah, so the hash values are all these float numbers. Now again we show working over here. Show working. Let hash value to document list mapping per band equal get hash value to document list mapping per band of signature matrix BR number of docs. For hash value to document list in hash value to document list mapping per band. For hash value in hash value to document list, print hash value to document list of that hash value. So this will print all the document IDs. So it prints 0, 1, 2, 12 and so on. Some of them have length 1, some of them have length 2. Hash value here we will show working. Let hash value to document list mapping per band equal get hash value to document list mapping per band of signature matrix BR and number of docs. For hash value to document list in hash value to document list mapping per band, for hash value in hash value to document list, if length of hash value to document list hash value is more than 1. So some of them are of length 1, so we don't want of length 1, we want 2 and more. So print length of hash value to document list of hash value. So it prints 1, 6, 4, 2, 3, 10, 4, all the lengths that are more than 1. Show working. Let hash value to document list mapping per band equal get hash value to document list mapping per band of signature matrix BR number of docs. For hash value to document list in hash value to document list mapping per band, for hash value in hash value to document list, print hash value. So it prints this 20530, 1296 and so on. Let hash value equal one of these, say 4176.0. Now let's find hash value to document list of hash value. So what's the so these are the hash value, and again, and if I want to print just the hash value, 6690, okay, let it be. And hash value to document list of this 3429, text of length 1. Okay. Show working. Number of docs. Let number of text equal length of hash value to document list of hash value. Number of docs. Text 1. We don't want 1. We want more than 1. So yeah, we don't want 1. Otherwise, this is going to retain nothing. I'll just show you. What this function does, it calculates the pairs. So pairs equal, let it equal to empty set. For doc ID 1 in range, number of docs. And range number of docs is for 0. And for doc ID in range, doc ID plus 1, that is 1 to number of docs, and number of docs is 1, so it's nothing. So that's why we want it 2 or more. So yeah, so we need to choose this. So we need to put this condition over here. Um, Print hash value. Okay, so these are the hash values that give the length of documents more than or equal to 2 documents. So say let hash value equal 7.0. So 7.0. So we see that all these documents are printed. So let number of docs equal hash value to document list of 7.0. 344 number of documents. So number of docs equal 344. Let pairs equal empty set for doc ID 1 in range number of docs, and for doc ID 2 in range doc ID 1 plus 1 to number of docs. So if doc ID is 4, then doc ID 2 will be in the range 5 to number of docs. Print hash value to document list of hash value, which is all those document IDs for the hash value 7.0, and doc ID 1 and hash value to document list. So all those documents for hash value 7 and doc ID 2 position. So the document in doc ID 1 position, comma, the document number in doc ID 2 position. So when we print that will print like this. So when doc ID 1 is 55, then doc ID 2 is 63, 55, 76, 55, 77, and so on. And if I put another set of bracket around that, gives this. Now show working. So pairs equal empty set for doc ID 1 in range number of docs. Remember we have for showing as an example, we have chosen number of docs to be for hash value 7.0. For doc ID 2 in range doc ID 1 plus 1 to number of docs, pairs dot append hash value to document list hash value. So all those documents so in the position doc ID 1 and the document number in the position doc ID 2. And if I run that, it gives me error. It says index out of range. So number of docs is 7.0. Wait. Okay, so let's have a look. Doc ID. What is the hash value? Hash value should be, we had chosen it to be 7.0, 2.0. Let it equal to 7.0 as an example, because hash value to document list hash value okay length and number of docs number of documents equal length of this print number of documents that's 321. Now if I run this, it should run. Okay, and if I print the pairs, then it will print this. Now this definition over here, it creates pairs for given list. For example, sample input is in array form 1, 2, 3. Then the sample output is 1, 2, 1, 3, and 2, 3. Definition get pairs. Input is doc list, and doc list is the doc list will be hash value to document list of that hash value. So number of documents equal length of doc list, pairs equal empty array. For doc ID 1 in range number of docs, that's the length of the hash value to document list for that hash value. For doc ID in range doc ID 1 plus 1 to number of docs, pairs dot append of pairs doc list at that position doc ID 1 comma doc list at that position doc ID 2 and retain pairs. Show working. So this is another definition. So let's run this function and let's run this function. Now this function over here, let hash value to document list mapping prebend equal get hash value to document list mapping prebend of signature matrix comma b comma r comma number of docs. Let candidate set equal set open and close bracket, so that will create empty set. For hash value to document list in hash value to document list mapping prebend, that's like in dictionary form. For hash value in hash value to document list, so hash value is the first the key value. If length of hash value to document list at that hash value, so the length of the documents is greater than 1, then pairs equal get pairs hash value to document list hash value. So it calls the function get pairs, which is this one, and the input is hash value to document list at that hash value, where the key value is the hash value. For pair in pairs, candidate set dot add pair. So in this candidate set, which is empty set, it will start adding pairs one after the other. So if I run that, and if I print the candidate set, it prints like this. And it is enclosed by the curly braces, as you can see. Okay, let's go to this one. So this definition over here, or function, hashes all documents using B bands and R rows per band. Then for all buckets with multiple documents in each band, generates candidate pairs and retains the final set of candidate pairs after removing any duplicates. So definition: get candidate pairs of signature matrix B, R, and number of docs. Let hash value to document list mapping per band equal get hash value to document list mapping per band of signature matrix PR number of docs. So that calls this function get hash value to document list mapping per band, and it finds all the mappings. It will be in a dictionary form. Let candidate set equal empty set, open and close bracket, for hash value to document list in hash value to document list mapping per band. So for each of the hash value and the document list, for hash value in hash value to document list, so the hash value, the key value, if length of hash value to document list of hash values, so that's the number of documents, if the length is more than 1, then pairs equal get pairs. So it calls the function get pairs, and the input is the list of documents. For pair in pairs, candidate set dot add pair. So to the empty candidate set, it starts adding the tuples one after the other, and this function retains candidate set. Okay, so for the let's run that. For this, we are working with number of hash functions equal 100. We want to work with 100 hash functions, and as that gives the least number of mean average mean estimate error. Hash functions equal generate hash functions, number of hash functions, number of words. So we are calling the generate hash function, the function that we created, generate hash functions, and that will create 100 hash functions. And the input is the number of hash functions and the number of words. Now, the number of words, let me show you, show working. The number of words, we know the number of words is 6,906 something. Yes, number of words is 6,906. So when we generate hash function for 100 hash functions, that will print 100 hash functions like this, right? And let's delete this cell. Okay, now then let signature matrix equal compute signature matrix of hash functions, comma words per I doc. So hash functions are the 100 hash functions that we have generated, and it will signature matrix calls the function compute signature matrix, and the input is the all the 100 hash functions and words per doc. So a words per document. So let's find what is the words per document. Words per doc. Yeah. So it's the words per doc for document ID 0. The words for that document are all these, and so on. So let's delete this cell to save the space. So yeah, so signature matrix calls the compute signature matrix function, and it retains the signature matrix. So let's retain the signature matrix. It will retain the signature matrix. Now, while it's doing that, in one of the labs before, we showed how this compute signature matrix works, and the signature matrix is this one. Now, next line, let candidate pairs equal get candidate pairs, bracket, the the inputs are signature matrix, optimal values of B, R optimal, which is the optimal value of number of rows per band, and number of documents. And number of documents is, we already know number of documents. Let's print number of documents. Text 321. Number of documents is much more, but this is the last digit of number of documents. Yeah, so somewhere we let, we manually let number of documents. We don't want that. No, we don't want that. So get universal hash function. Number of documents should be 3430. Yeah, number of documents is 3430. We will manually enter number of docs equal 3430 here, because we know that number of documents is 3430 from the previous lab. Now, if I input that, if I run this, it will print the candidate pairs. So all the candidate pairs are printed over here. For all the 3430 documents. Okay.